My name is Aquino, my partner is Raúl Cedes, and we are the students working on the research project called A Virtual Instrumentation Environment for Characterizing Dielectric Absorption in Integrated Capacitors. Our supervising professor is Dr. Manuel Jiménez of the Department of Electrical and Computer Engineering of the University of Puerto Rico. And today we will be giving an overview on what the central problem of our project is, our objective, the methodology we will employ, and the results we expect.
Hello, my name is Raúl Cedes and I'm the second student working on this project. The electric absorption is a phenomenon occurring in capacitors that has been discharged and suddenly recovered part of its initial voltage. Depending on the type of circuit, this phenomenon adds an error percentage from 1% to 25% in worst case scenarios. Thus, effort is placed into the design of methods to take measurements of the electric absorption of a capacitor in order to ascertain the quality of this electric element and the lifespan. However, accurate measurements are difficult to achieve in contemporary integrated devices, where currents and voltages become comparable to parasitic elements. The central problem will be, how can we design a method in which we can minimize the source of error and accurately measure the dielectric absorption of an integrated capacitor?
The objectives for this project are studying and performing a systematic analysis of the setup circuit parameters that affect the dielectric absorption measurement test, called DAM test for short, developing a robust test board that allows for an accurate DAM test, integrating a test measurement architecture capable of producing the excitation and acquiring the measurements for the DAM test, developing a virtual instrument environment using LabVIEW that allows for the automation of the process, perform an experimental evaluation of the accuracy effect of modifying the circuit, assessing the statistical significance of the acquired measurements through a well-designed experiment, and evaluate the introduced modifications under various use scenarios and provide recommendations into which modifications become more appropriate to use given the circumstance.
We will use Cadence tools and LabVIEW for the following: the development of SPICE models to assess circuit performance in a simulated environment, construction of circuit setup to excite CUTs, experimental design to assess the relative effect of circuit modifications, analysis of extracted data to assess the competitive advantages of the introduced setup modifications, and the development of a LabVIEW environment to carry the DAM test in a production line environment.
At the end of this project, we will have developed the knowledge of how to perform a dielectric characterization process, investigated the effect of different setup configurations, and will develop a virtual instrument environment using LabVIEW, able to automate the data acquisition process and the analysis.
We would like to thank you, viewers, on behalf of the University of Puerto Rico for watching. If there are any questions, contact us through the AAP page. Thank you.